Hi, this is the second in a series of 3 videos that explore the mandatory data entities within an Evoke app. The first video looked at the 3 mandatory entities and explored the purpose for having these entities within an app. That's the app user group, and the classification entities. This video takes those 3 entities and explores how we can map those entities within our data model onto our multi-value database server. I'm going to basically start from scratch here. So the first thing that I need to do is to define the presence of our multi-value database to Evoke. And you do this within the repositories page. I'm going to add a repository. I'm going to give it an ID, let's call it MV, select the technology, it's multi-value. The platform, I happen to have a JBase database here, could be any of the other multi-value platforms though. And the connection type for JBase is going to be MV.NET's core objects. The connection string for an MV.NET core object connection is simply the login profile that we create using the data manager, and that's SOP in this case. Save those details. Now that we've established the connection information to our repository, one of the things that we can do is to use the scan for repository objects, and that goes away and retrieves back the list of files that we've got defined within that account. And this just allows us to select from a drop-down list later on when we're identifying which files a particular entity is mapped onto. So I'll save those details. Now that we've defined our repository, we can then move on and describe the data mappings that basically describe how the entities and properties of those entities within our data model map onto things within our multi-value database. So if I click on this repositories row, Evoke goes away, it looks for any mapping information that already exists, and of course in this particular situation it hasn't found any because it's a brand new repository. In fact, if we click on the show new mappings, that just highlights the fact that all the properties and all the selections of all our entities are viewed as being new mappings, which of course they are. What we have within the content in the lower half of this page is the list of entities within our model, and as you click on one of these entities, you can maintain the mapping information that describes how the properties of the entity are mapped onto attribute positions within the database structure, and you can also define how selections are to be executed down on the database server. Strictly speaking, you don't have to map an entity onto a specific file or repository object, as they're called here. Really what we're doing here is we are describing the structure of a data blob that moves between C# and our multi-value database environment backwards and forwards. Now it might be that the structure of this data blob that we describe maps onto the structure, exactly onto the structure of a file, in which case things are really easy because you can get Evoke to do all the work for you. However, in those situations where your entity model does not map onto exactly the structure of your file system on your multi-value database, you will need to write some data basic code that will receive and send back data in the structure that we're going to describe here. But in your data basic code, you'll be responsible for kind of teasing apart that data blob and reading and writing to the relevant file or files down on the database server. Now, in this situation that we're about to do here, we have got a pretty much one-to-one mapping between our entities and files and our entity properties and attribute positions within those files. So in fact, Evoke can do all of the work pretty much by itself. But what I will do after I've created this data mapping information is take you into the multi-value database, and we can have a look at how, if you wanted to, you could drop your own custom data basic code into the pipeline so that you can take control over the reading and writing at the very bottom level of your data. Right, so let's start this data mapping process going. We've selected our app user, and the first thing we need to do is to indicate which repository object it's bound onto. And then this is where the scanning for repository objects that we did in the previous page allows us to choose from a drop-down menu. So in fact, I want to choose the app user file. That's great. This particular file has got a structure, and we can have a look at that structure if we go into the data manager and connect into the particular database. And if we have a look at the schema of the app user file, here we have the attribute layout. So what we want to do here, because we've got a file that maps pretty much exactly onto our entity, all that we need to do is to tell Evoke which attribute position each property is mapped onto. So let's go through that process. So login name and password is 1 and 2, and for each of these we're going to choose a data type. They're both alphanumeric. First name and last name are 9 and 10. Again, they're both alphanumeric. Date created and date last logged in is 7 and 4. And we'll mark these as being date. Now, these data types are important because the data that moves between the middle tier C# code and data basic is moved in internal format. So the date information in this case will be multi-value internal, the date since the 31st of December 1967. So the C# needs to know what the data type is so that it can do the conversion necessary in order to get the date into a .NET date format and ultimately into a JavaScript date object. Culture and current auth token is 6 and 5. Okay, just to talk a little bit about these two properties. The current authentication token is an internal thing that Evoke uses in order to provide data security. It basically stops people from just being able to poke HTTP requests into the web service. The culture is also very important, and that controls the internationalization that Evoke automatically uses and incorporates into the UI tier. And that uses the international ISO 4-digit character internationalization codes. Then we've got created by which is the 8, and the account is 3. Now the account isn't actually used at all in this app. This app that we're doing here has got no concept of an account as such, and they're created by is alphanumeric. So those are the mappings for the data that sits directly within the app user file. You notice that there is a second tab called related data, and any properties of the entity that you've selected that are of type entity will be listed here. And in fact, the app user does have an entity property. It's its user groups property, which, if you remember from the first video, is basically a list of the app user groups that a particular user belongs to. In this particular file, the user group information is held as a multi-valued list. If we go back here, we can see that in fact it's flagged within the MV.NET schema as being a multi-valued group, even though there's only one field. So that means that we need to indicate the attribute position that this group relates to. So it's 11. Okay, there's 11. And the entity key storage we need to flag as being an embedded multi-value. And this indicates that we don't need to start joining and retrieving data from another file to get this information about this particular entity property, because it's embedded within the parent entity itself. What we've also got for the app user entity is we've always got a selection that is used by the login process. And this selection is used to select out all of the items that match the login name that is entered by the user. And in fact, I'll enter this later on and come back to this. So that's the app user entity. If we now move on to the app user group, this has only got one property called group name. And this relates to the user groups property that we've just dealt with within the app user. And the attribute position that we need to put in there is attribute position 1, because it's the first piece of data from attribute 11. It's a little bit trivial here because we've only got one property, but if you imagine that we'd got an embedded entity that had got maybe half a dozen properties making up its structure, then each of those would have an attribute position, and therefore the attribute position that we fill in here is basically the logical position within the overall group that we identify that we need to reference in order to extract the data. Again, we need to give that a data type. There are no selections set up for this one. Classification. I'll be talking about classifications in another video because it warrants a discussion in its own right. But what we have got within this particular application is classification and status codes and category codes actually spread around in 2 or 3 different places within our database, and that's probably quite typical. So what this is describing here is the structure of the data that the the data basic layer has to prepare and send back, well, and receive as necessary, in order to make classification data available. And so we're going to say that the code is attribute position 1, type is 2, description is 3, that's 4, 5 and 6, and these are all alphanumeric fields. Set those there. And again, there's no related data and no selections for the classification entity. The two entities that we've created specifically for this app, what I forgot to do is to choose the repository objects for these two. So I'm going to choose classification as that there. The customer maps onto our organization file. And if we have a quick look at the structure of this guy, we've got the name as attribute 1, that's alphanumeric, is on hold is Boolean, and that's attribute 5. That's a Boolean value, and on our database we regard the value 1 as being true, so that goes in the data conversion. Date the account was opened. We haven't got that in this database, but for the time being I'm just going to put that down as attribute 8. Mark that as a date. So in fact we don't have to have dictionary items defined on our database for multi-value, because the Evoke is only really interested in this data blob that moves backwards and forwards. The only reason why dictionary items are important is because you may want to reference them when doing selections and other pieces of work inside your data basic code. And the address is a multi-valued field. I'm going to, so what was that? Quick look again, that's at number 3. Mark that as alphanumeric. And then our product is mapped onto our product file. And have a look at the structure of this guy. Description is 1, buy and sell 2 and 3. That's a currency value, and that's a currency value. That's okay. I'm now going to save that information. And what we've just done here is to provide the generator with enough information to firstly create a whole layer within C# that is responsible for coordinating the interactions with the backend database according to things that happen inside the UI. And the second thing that we've given to the generator here is information that it can use to generate the backend databasic code that sits in parallel with the C# layer and acts as the other end of the pipeline in terms of passing data backwards and forwards. So now that we've done that, the final thing that we need to do is to obviously generate code. At the moment we've only got a generator profile that's really there to work with an SQL database. So the first thing I'm going to do is to create a new profile, call that MV, and the first thing that you need to do is to identify which repository, if I just make that capitals, which repository each of the entities is found within. in this case it's within our multi-value repository, so it's nice and straightforward. But we could actually have a mapping that allows 2 or 3 entities to get their data from one data environment and some other entities to get their data from a separate, different environment. We want to generate our code to our file system. I'm just going to pinch the settings from here. And I'm going to put MV on the end. Save that. And we're pretty much good to go now in terms of generating a multi-value database version of this app. But the final thing I want to do is to tick all of these here. Because what I'd like the generator to also do, in addition to generating our Visual Studio code, I want it to connect into our multi-value database and create what we call our CRUD code within Data Basic within the account. And what we'll do when that's been done is to go into the MV.NET Data Manager and have a look at the code that's been generated. So I'll start the code gen going. So it goes through, creates a Visual Studio solution, generates the relevant code based on our design, and then goes through and generates our repository code. So that's now connecting through to our backend multi-value database, and when it's finished generating all of that code, it will throw up this message saying, okay, a number of routines have been created within our evoke.crud.bp file. That's the file that Evoke expects to be there already. So it's important before you run this CRUD generation process that you have created a file called evoke.crud.bp, and that is a file type that is able to hold compiled programs before you run this process. And in fact, what you'll need to do is also to compile and catalog the things that have been created within that file. If we now hop into the data manager, I'll close these guys down, and we have a look in the Evoke CRUD-BP, we'll see the routines that have been created for us. And what you can see is that we've got 2 subroutines per entity. One that is in effect owned by the generator, and another one which in effect is owned by you, the developer. And the basic idea here, if we have a look at the, well, let's have a look at the app user one to begin with. All of the versions of the routines that are owned by the generator start off with a call down to their custom counterpart, and the custom counterpart is really just a big switch statement here where you can plug in the relevant data basic code that is required to deal with the various types of CRUD actions that can be initiated by stuff happening within the UI. Now, if you don't actually do anything here, then the automatic code will just carry on and try its best. It will assume that you've got a situation where your entity structure maps pretty much directly onto the file structure. So if you do actually want to take control over CRUD, it's important within your custom routine that you set this return argument action completed to true, and that basically tells the generator owned version that it doesn't need to do anything and that it can simply return. And that structure is used all the way through the generated code. Now, once the Evoke generator has created this custom version of the routine for the entity, it will not touch it again. And one thing that I do need to mention here is that the CRUD download that we just did within Evoke assumes that you've got a small subroutine in place that the downloader can interact with, and this is that subroutine. So before you start doing CRUD download within Evoke, you need to have created this small subroutine and catalogued it so that it's available to the downloader to make use of. And in fact, a copy of this code is within the Getting Started guide that we provide with Evoke. Okay, so we've been through how the data mapping can map onto files within the database structure. We've seen how we can generate code, both the Visual Studio code and also the backend data basic code. What I will explore in another video is how you can deal with a situation where there is not a clean mapping between your entity model and your file system. And basically that will require you to write some data basic code. Because that will probably take about 10 minutes to describe, it's not included as part of this video. The video that follows on from this one talks about how to do this process against an SQL database as opposed to the multi-value database that we've been dealing with. One of the things I promised to do was to go back and explain a bit more about the selection that we've got against our app user entity. So if we go back to the Evoke, go back to generator, you can see that for the app user we've got this opportunity to enter a filter and select clause into our data mappings. Now at the moment they're obviously blank. If we go back into the generated code, so here's our app user CRUD item, and if we scroll down and have a look for the section that relates to select, here it is, and we can see that this is the generated code that's been created to handle the select by name selection if the custom routine doesn't decide to, if the custom routine decides that it doesn't want to take over the implementation of this selection itself. And at the moment, as you can see, all we've got here is a select that's going to bring back the content of the whole file, which isn't quite what we want here. So the solution is either to roll your sleeves up and to go into the custom routine and in the selection section here write in, drop in a section of data basic code that does whatever you need to do in order to implement this selection. And of course this is what you would do if you'd got app user login data stored somewhere else within your data structure, or if it was spread into 2 or 3 different files, for example, etc. But in this case we can actually get the generator to produce exactly the required data basic code automatically, and let me show how we can do that. Go back into Evoke, and what we want to have happen here is a selection that takes the login name that's been provided by the UI and selects out all of the records for our app user file that match on that login name. So what we want to drop in here is in effect a multi-value syntax with clause that the generator can use to create code that does that filtered selection. And so what we want to do here is reference. So don't forget, this is now talking multi-value language here, because we're inside a data mapping that is associated with a multi-value database. So the things that you refer to here are dictionary items within this app user file. So what we want to do is select out all of the items that have got a login name upper. Now if we have a look at login name upper, we can see that this is a dictionary item that does an uppercasing correlative. So it just makes the selection case insensitive. Now if you want to use this approach, there is some syntax that you'll need to make sure you use within the filter clause, and let me just type it in and explain it to you. So what I will do is I'll just zoom out a bit to give us a bit more space. Yeah, so the login name. So what I'm typing in here is the name of the filter argument that we've defined within our entity model. So if we go back and have a look at entities and have a look at the selections, it's the name that we've entered here. So what we're defining is that whatever the UI supplies as this login name filter argument, that is going to be dropped into this filter clause here. And in fact, not only do we want the login name to be dropped into this filter clause, but we want an uppercased version of the login name to be dropped in. So we're going to use this special syntax here, MCU, directly after the actual name of the selection filter argument. And let's not forget our double quote. We don't have to have a sort clause, but you know, we could sort by login name if we wanted to. So essentially what we've done here is we've given the generator enough information for it to produce within the generated CRUD the correct data basic to select out all of the items that match in a case insensitive way the login name that's been provided within the login page. So if we save that, go into the generate, and what I want to do is to just generate the CRUD for our app user entity. So I'll just tick that one because we've updated our data mapping information, and some of that data mapping information is relevant for generated CRUD. So we'll tick that, and it will force the generator at the end of its creating our Visual Studio code to move on and generate the CRUD for the app user entity. Now it's important to note here that it will not regenerate the custom code item for app user. It will only create ev.crud.appuser again. Now if we go back and have a look at our CRUD code, that's the wrong file, beg your pardon, come back, we can now see that as we scroll down to our select section, we've now got some extra code in there that is making use of that filter and sort information in order to correctly implement this selection.